Good day to you all. I welcome you all in today's physics class. I'm Nudit Sampson. Today our topic is Newton's laws of motion. In physics, today we are going to discuss Newton's laws of motion. Sir Isaac Newton, he was an English scientist and mathematician, famous for his discovery of the laws of gravity and the three laws of motion. Today, these laws are known as Newton's laws of motion, and they describe the motion of all objects on the scale we experience in our everyday life. We apply forces on an object, but what do forces directly affect? Is it location, velocity, acceleration, or the jerk? Newton answered these questions by postulating three laws of motion. Imagine yourself practicing for 100-meter race on a track and somebody asks you to stop immediately within a second. Will you be able to do it? What if you are suddenly asked to turn around the right? Will you be able to turn towards the right immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? If the same story with every object will continue to do what it's doing. If it's in motion, it will stay in motion. If it is at rest, it will remain at rest. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change its direction. And this is nothing but the Newton's first law of motion. Here's the correct definition of the first law of Newton. An object at rest stays at rest, and an object in motion stays in motion, with the same speed and same direction, unless acted upon by an unbalanced force. In simple words, it means that the object continues to do what they are doing, unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, and an object will be in motion at zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second case, the object will continue the motion with the same velocity and the same direction. Don't forget these two cases will remain true only if the forces are balanced. Newton's first law of motion says an object at rest stays at rest and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. Now the important question is what happens when there is not force acting on an object? That's precisely what the second law of motion discusses. If the forces are balanced, the acceleration will be zero. In first case, the object will continue to remain at rest, and in second case, the object will continue to stay in motion with same velocity and same direction. Don't forget, these cases will be true only if the forces are balanced and the net force is 0. Now let's create a simple diagram for the second case. If the forces are unbalanced, then there will be an acceleration. Now we come to the interesting part. Let me ask you a question, and I'm sure you can answer it. One of which two factors acceleration will depend on? I want you to tax your brain a bit. Let me repeat my question. On which two factors do you think will the acceleration depend on? Okay, let's say there is an object on a table. You apply a force of 10 units on it, and then you apply a force of 20 units on it. In which case do you think the acceleration would be more? The one on which the force was more. So we can say that one of the things depends on the acceleration is a net force. If it is more, then the more will be the acceleration. If it's less, then the lesser will be the acceleration. Acceleration directly depends on the net force. Come on now, I wanted you to think about the second factor the acceleration depends on. Let's say there are two objects on the table. One has the mass of 3 kg and the other has the mass of 5 kg. Now if you apply a force 10 newtons on the both, which one do you think will accelerate more? Surely it's the 3 kg one because it has the lesser mass. Lesser the mass, more will be the acceleration, and more the mass, lesser will be the acceleration. Hence we can say that acceleration depends inversely on the object's mass. If you understand this concept well, then understanding the second law of motion will be very easy. Mathematically, it can be written like this. Acceleration is equals to net force upon mass. In simple term, acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. That's the second law. Or as more people understand it like this. Net force is equals to mass of an object into acceleration. Net force is the product of mass and acceleration. With this, can you tell me the units of force? Standard unit of mass is kg and of acceleration is meter per second square. So, unit of force is kg multiply 1 meter per second square. This is what we call a Newton. So we can say that 1 Newton is 1 kg times meter per second square. So if the mass of object is 10 kg and acceleration is 10 meter per second square, then the force is equals to 10 into 10 and the force, net force, will be 100 Newton. So we can say that 1 Newton is defined as the amount of force required to give a 1 kilogram mass an acceleration of 1 meter per second squared. Newton's third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. Let's see this example. Tires of a car push back against the road while the road pushes the tires forward. Action is tire pushes on road and the reaction is road pushes on tire. In the second example, force of finger on wall, force of wall on finger. Here the action is air rushes out and the reaction of the balloon is balloon goes up. These examples prove the Newton's third law of motion, that every action has an equal and opposite reaction. Now coming to your homework, you have to state Newton's laws of motion with examples in your copies. Stay home, be safe, wear mask, protect yourself and follow SOPs for COVID-19 given by WHO, World Health Organization and Government of Pakistan. See you in the next session. Till then, bye-bye. Students, do all the homework given to you from the first lesson till the present one in your copies. Marks will be given to you on the basis of your homework and activities.